So I'm going to cover some codes regarding image filtering and segmentation. So this is also one of the processing methods, digital image processing methods. Going for filtering, so initially we'll start with the filtering and then slowly we will converge how we are going to go for segmenting an image as well. So coming to the mechanics of filtering, it is mainly called as point operations or neighborhood operation. So you consider this one as a full-fledged image. So any image is considered to be a two-dimensional space. We are going to have some x coefficients, we are going to have some y coefficients. So we are going to regard it as a two-dimensional space. So I am going to consider something called as a mask. So this mask is also called by other name called as a kernel. So whatever it is, this is going to be a very small image. So this may be some 3 cross 3 image or 5 cross 5 or 7 cross 7 as the case may be. And this mask is going to act upon this entire image. So it is not going to act upon this entire image at one stretch. So I am going to have this image cut into so many sub-images. So again, possibly I may cut short into 3 cross 3, 5 cross 5 or 7 cross 7 as the dimensions are. And this mask is going to act upon each and every sub-image. And finally, we are going to get the result. So the pixel under consideration will be replaced with the computation, whatever value we got after performing this computation. This computation is basically so this is how we are performing that. So here this is what you call as the mask. This is moving on across the image. This will move across x direction and then the y direction. It is very much like as you read a book. So it goes on. And the pixel under consideration, you can see the target being shown here. So the pixel under consideration will be replaced with a computed value. So this computation is basically a convolution. So hope you people are familiar with convolution. So it's a very basic operation that is being performed. So in this case also, we are going to perform the very same convolution operation. So this is what is called as filtering in images. This operation is what you call as a filtering in images. So since we are doing this filtering in the spatial domain itself, that is in the domain where the physical image, the digital image is available, we are doing in that domain itself. So it is called as a spatial filtering. So normally whenever you say filtering, it is a demarcation between wanted and unwanted. So the term filtering is available and applicable everywhere in every domain, in every field. So in whichever place we are applying that filter, it takes the different parameters into consideration. So in this case, since we are considering with regard to images, filtering refers to replacing the one pixel value by another pixel value which will more align with the image. Or in other cases, filtering out the noise. So removing the noise pixel and putting a suitable pixel in that place. Or removing an unwanted pixel. Sometimes there occurs some unwanted pixel because of errors in the image, or because of any degradations in the image, or because of any other reasons, blur or camera lens problems, all these things. So replacing the pixel which is having an erroneous value by another value which is more suitable to the image, which will more align with the rest of the image. So this is what you call as a filtering. So since it is performed in the spatial domain, these techniques are called as a spatial filtering. It is basically a convolution